Alright, in this video here we're going to talk about solving a triangle, and we're going to do an example of that. So, first off, what it means to solve a triangle is to find the lengths of all three sides of the triangle and also the measures of all three of the angles. So it's basically getting all the information about the triangle. All the sides, all the angles. If you know all of that stuff, you have solved the triangle. Right, so here's an example of a triangle that we are going to solve. So it's triangle ABC. Notice we have angle A is 30 degrees, so we're given that. We're given that angle C is a right angle, so we have that one. And we have the hypotenuse side is 12, right? And what we don't have is angle B, and we don't have sides A and B. Now, just a quick word about how we label a triangle. The general way we do it is we label the angles with capital letters, and then the sides opposite the angles we label with the lowercase of that letter. So if this angle over here is angle capital A, the side opposite that is lowercase a. Right? If this is capital B angle, the side opposite that is side lowercase b. Right? And this is angle C, then the 12 over here will correspond to side C with a lowercase c. Right? So that's just the conventional way that we label triangles, just so you're aware of that, because you'll probably see similar things in other problems that you do. Alright, so we need to solve for all of our sides and all of our angles. Probably the easiest thing to do is to solve for our angles first. I already know two of the angles, right? I know angle A is going to be equal to 30 degrees, right? I'm given that. I don't know angle B, but I know that angle C, since it's a right angle, is going to be 90 degrees. Right? So what does angle B have to be? Well, this goes back to a known fact from geometry, and hopefully it's something that you remember. The three angles of a triangle always have to add up to 180 degrees. Right? So 90 plus 30 plus angle B has to equal 180. Well, 90 and 30 adds up to 120. So if I do 180 minus 120, that leaves me with 60. Right? So angle B has to be 60 degrees. Right? Then the three of those will add up to 180. Right? So that's the first thing. If you know two angles of your triangle, just add them up and subtract it from 180, and that gives you the measure of that third angle. Alright, so we've got all our angles now. That's like I said, that's the easy part. Now we have to find the two missing sides that we don't know. Alright, and to find those two missing sides, I'm going to have to use some trigonometry. Right? I can't just rely on geometry to do this. I need some trigonometry. It's a little bit more powerful. Right, so I know angle A is 30 degrees. That's what we were given. From that 30-degree angle, right, the side A is the opposite side. The side that's labeled 12 is the hypotenuse, and then the side that's labeled B would be the adjacent side. And let me actually put letters here so that instead of just one single letter, I don't want to put like a capital A here for adjacent, because that might get confusing with the other capital A that we have. Right, so this is adjacent, opposite, and hypotenuse. Right, so if I want to find side A, well, side A is the opposite side from my angle. So which of the trig functions relates the opposite side with the side that we know, which is the hypotenuse? Right, so that's the way you have to think about this is, all right, I have this angle here. What is this side I'm looking for in relation to that angle? All right, that's the opposite side. What side do I know? The hypotenuse. All right, so I need to relate the opposite side with the hypotenuse side. And which of the trig functions is the opposite over the hypotenuse? That's the sine function. Right, so it goes back to those definitions of the ratios of the trig functions in terms of the right triangle. And if you haven't seen the video that I did about those definitions, you should definitely watch that, because they're definitions you need to know. Right, and remember, the way to remember that is SOH CAH TOA. Right, sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Right, so I'm looking for the opposite side. I know the hypotenuse. I need the OH, which means I need to use the sine function in order to do that. Right, so the way I'm going to set this up, let me kind of get rid of this right here. The sine of angle 30 degrees is going to equal the opposite side A over the hypotenuse side, which is 12. Right, so sine of 30 degrees equals A over 12, and now I can solve that equation for A. Right, because I have an equation where I have things filled in for everything except for one single variable. Right, that's why I had to use the opposite and the hypotenuse, because I need to have a number here. Right, I couldn't use the opposite and the adjacent, because then I would have A over B and I would have two variables. I can't solve that equation when I have two variables there. All right, so to solve this for A now, I need to multiply both sides of the equation by 12. Right, so 12 times the sine of 30 degrees is going to equal the length of side A. And now we got to figure out what's the sine of 30 degrees. Right, but before I do that, just real quick to go over what we did, just to make sure that, like, this is the key thing here, that if you understand how we put this equation together, then you know how to do these types of problems, and you'll be fine with it. I know this angle. I need this side right here. I know this side. So I need to think of which one of the three trig functions, is it sine, cosine, or tangent, which one of those three relates this opposite side with the side I know, the hypotenuse. Right? Remember, I need to use a side that I know so that when I write the equation, I only have one unknown there, one variable. Right? So I think of SOH CAH TOA. I need the opposite. I know the hypotenuse. I need to use the sine function because that's SOH. Sine is the opposite of the hypotenuse. So I set that up, and then I do what I need to do, move stuff around to solve for A. And now we got to figure out 12 times sine of 30 degrees. Well, 30 degrees, that's one of the numbers we know from the unit circle. Right? If you haven't seen the video that I did about the unit circle with degree measures, you should check that out. But 30 degrees is the first one we see in the first quadrant. And 30 degrees corresponds to pi over 6, which if we use our trig hand is the ring finger. The terminal points are root 3 over 2, comma, 1/2. I wish I wrote that kind of sloppy there, but root 3 over 2, comma, 1/2, right? So that's my terminal point for 30 degrees, or pi over 6. And my sine function, sine of 30 degrees, is the y-coordinate. So sine of 30 degrees is going to be 1/2. So it's going to be 12 times 1/2 equals A, which means A is equal to 6. Right? So side A equals 6. I don't know side B. I know that side C equals 12, because that's the one I'm given, right? The lowercase c is the side opposite from angle C. All right, so I've got side A, and now I need to find side B. All right, so again, I figure out this is the angle I know, this is the side I know. I want this side. Which of the trig functions relates the opposite and the hypotenuse? That's the sine function, so I set up the sine of this angle, 30 degrees, equals the opposite side A over the hypotenuse, 12, multiply the 12 over, use my unit circle to find the sine of 30 degrees, right? Use the trig hand. Again, if you haven't seen the videos I did on unit circle and trig hand and how to evaluate those trig functions, you definitely should check those out, because you need to be able to do that to solve a lot of different types of problems, right? This is just one type of problem, solving a triangle, where you can use the unit circle and use your trig hand to figure out the numbers you need. But there's plenty of other types of problems as well where you have to do the same thing. All right, so that's finding side A. Now I want to find side B. All right, so to find side B, I'm going to erase this that I did here, the work I did to find side A. I have to do something similar to find side B. All right, now, I still know this angle of 30 degrees, but now side B is my adjacent side. So I want to use the trig function that relates the adjacent side with the hypotenuse. And that's going to be the cosine function. All right, so cosine of 30 degrees is going to equal side B over 12. All right. So once again, it's just like I did for side A, and I used the sine function because side A was the opposite side, and sine is the opposite over the hypotenuse. Remember, cosine is the adjacent, right? That CAH in SOH CAH TOA, cosine is the adjacent side, B, over the hypotenuse, 12. Right? So I set up cosine of 30 degrees, that's my angle, equals B over 12. And now it's a lot like what I did before. I multiply that 12 to the other side to get the B by itself. So I get 12 times the cosine of 30 degrees equals B. And then once again, my angle is 30 degrees, so I go to my unit circle. I already have the 30 degrees there. I already have the terminal point. Cosine is my x-coordinate of my terminal point. And my x-coordinate is root 3 over 2. All right, so it's 12 times root 3 over 2 equals B. All right, so once I get my equation set up, if this angle here is one of the angles I know from the unit circle, I go to the unit circle and I get the exact value from there. If this was like 33 degrees, and I don't have 33 degrees on the unit circle, I do cosine of 33 degrees in my calculator, and then I give the approximate answer, because it's going to give me some kind of decimal number that I'll have to round off, so I get the approximate answer. Right? But if it's a 30 degrees, 45, 60 degrees that we know from the unit circle, we use the unit circle to get the exact value. Right? And then 12 times root 3 over 2, the 12 and the 2 cancel out, so I'm going to get that B equals 6 times the square root of 3. All right, so B equals 6 root 3, and now I have solved my right triangle. I know the lengths of all three sides. I know the measures of all three angles. I have all the information about this triangle. All right, so that's solving a triangle. You know, when you're trying to solve for sides, you usually have to use the trig functions in order to do that. You just have to decide, you know, which side do I know, which side am I looking for, and then which of the three trig functions relates those two sides. Is it sine, cosine, or tangent? And it goes back to the SOH CAH TOA. Right? If it's the opposite in the hypotenuse, you're using the sine function. If it's the adjacent in the hypotenuse, you're using the cosine function. If it's the opposite in the adjacent, you're going to use the tangent function. Right? So knowing those definitions is super important to be able to set up these equations correctly and solve these types of problems. Right? One last thing for this problem is some of you watching this may have thought of this and say, well, why is he doing this when there's a much easier way to do it? There is an easier way that we could have found side B after we found side A. Right? Since we have a right triangle here, after I had sides A and C, the 6 and the 12, I could have then used the Pythagorean theorem to find side B. Right? It would have been 6 squared plus B squared equals 12 squared. Right? These two sides squared and together equals the hypotenuse squared. Right? So if you set up that equation there and solve for B, you should get B equals 6 times the square root of 3. Right? You'll have to probably simplify your square root that you get to end up with this. But if you do it all correctly, you should end up with the same result there. Right? So anytime you are solving a right triangle, once you know two of the sides, you can always use the Pythagorean theorem to find that third side. I chose not to do that since I'm trying to teach you, how to use these trig functions. I did it the way where we had to use the cosine function in order to figure it out, just to kind of go through that method one more time. But in reality, there was a quicker way we could have done that. So, when you're solving these problems yourself, feel free to go ahead and use the Pythagorean to get that Pythagorean theorem to get that third side. All right, so that's solving a triangle.